Okay, now that we've talked about sets and roster sets and the cardinality of sets and sets being equal or equivalent, let's look at something called a Venn diagram as a way to demonstrate what is contained in each set in a visual way. All right, here's a Venn diagram. The U stands for the universal set. Everything in this box or rectangle is in our universal set. That's everything involved. We see a circle here that is set A, another circle representing set B, and everything that's not in those is still in the universal set. Okay, so if we're asked to list the elements of set A in a roster notation, we would list A equals the brackets, and we list those sets preferably in ascending order from lowest to highest. So 4, 11, and 12 we can visually see are in set A, and there's the roster notation to show that. Question 2, list elements of A prime in roster. All right, what does that mean again? A prime is everything that's not in A. So we look over here, everything that's outside of the circle of A is in A complement or A prime. So basically all these, the 2, 3, 5, 13, 9, anything outside of there, even if it's in B, is in A complement or the complement of A. So listing them off, we see it's 2, 3, 5, 7, 8, 9, and 11. Okay. Now, what is the cardinality of B? The B with the 2 lines around it, remember, is the cardinality of B, and that again means the number of elements in the set B. So we can visually see that it contains a 9 and a 13, so it has a cardinality of 2 elements. All right. Question here about equal versus equivalent. True or false? A is equivalent to B. Okay, not equal, where it's exactly the same, but equivalent, meaning it has the same number of elements. So do A and B have the same cardinality or number of elements? Well, no. Okay, clearly we can see that B only has 2 while A has 3, so that would be a false. All right, so there's our basic introduction to reading Venn diagrams to answer questions about cardinality and things like that.